Chapter 13, number 34. An old car with worn-out shock absorbers oscillates with a given frequency when it hits a speed bump. If the driver adds a couple of passengers to the car and hits another speed bump, is the car's frequency of oscillator greater than, less than, or equal to what it was before, and choose the best explanation. So this is going to come back to the standard result from this chapter, which is that the period of a spring system is 2 pi times the square root of the mass over the spring constant. It's easy to see where they come from. The square root is a little trickier. That comes from energy conservation. But definitely the more massive you have, the slower the thing will go back and forth, the longer it will take, because it's harder to move the masses. And the stronger spring you have, the faster the masses will move back and forth because they snap more easily. So in this case, what we have is that increasing the mass increases the period. But increasing the period decreases the frequency. So we end up with that. It should be less than before, less frequent than before. And the proper reason is that increasing the mass increases the period. So exactly what we said here.